We begin Chapter 3 with a look at some specific kinds of angles that deal with intersecting lines. First, most of you probably already know this, but parallel lines are two coplanar lines that do not intersect. They look like this. Hopefully that looks familiar to most of you. There are actually two parallel symbols that we need to go over. First, I can write this. Line A is parallel to line B, which is fine. But parallel comes up a ton, and we really don't want to write that all the time. So instead there is a parallel symbol which looks like this. Hey, those kind of look like parallel lines. They are a bit longer, closer together, and extend farther down than two 1's or two lowercase l's would, but that's just to make sure you don't get them confused. Get used to that symbol. You'll see it a lot. But that's only the first parallel symbol to know. The other symbol has to do with a picture of the parallel lines themselves. Just like we can mark line segments congruent with tick marks, or angles congruent with arc marks, we can also mark lines up to show they are parallel. To do that, we have this symbol, an extra set of arrowheads. These arrowheads can appear anywhere on the line. They can also point the other direction. And they don't have to be red. I just made them red here so they stand out. Just like when we marked congruent segments with tick marks, there will be situations where a picture will have multiple pairs of parallel lines in it, like this. Here I have both line A parallel to line B, and line C parallel to line D. We have already marked line A and line B with single arrowheads, and you can probably guess what is coming next. But in order to mark line C parallel to line D, we need double arrowheads. You need to get used to these arrowhead symbols too. Just like the other parallel symbol, these come up a lot this year. Now we get to skew lines. Skew lines are also two lines that do not intersect, but they are not parallel. You will see by the definition of parallel that parallel lines need not be coplanar. Not so with skew. Skew lines are non-coplanar. Just three little letters added to the parallel definition turns it into skew. Skew is a little harder to draw and represent. This one is actually easier to do in person when holding two rulers. But skew might look like this. Here I have a box to try and show you a three-dimensional shape. And then if I highlight these corners of the box, these would be an example of skew lines. They never intersect. They just pass by one another and go on their merry way in completely different planes. In practice, skew lines are not nearly as prevalent or as useful as parallel lines. Skew lines are so rare, in fact, that they don't even have a symbol. When you don't even have a symbol, that's how you know you don't come around very much. Now we have parallel planes. Parallel planes needed to be coplanar. If you think about it for a second, that wouldn't work here. Coplanar planes would be the same plane. Parallel planes are planes that do not intersect. Here is an example. Those are the famous Blue Angels from the U.S. Navy. Sadly, those aren't the parallel planes we are talking about. An example of the geometric parallel planes we are talking about would be the ceiling and the floor of most rooms, assuming, of course, that they are correctly built perfectly parallel. In that case, the planes that contain the ceiling and floor would go on forever and never touch each other. Here is a picture example of parallel planes. Here I have attempted to kind of show a parallel ceiling and floor. Now we get to a transversal. A transversal is a line that intersects two or more coplanar lines at distinct points. If you know your Latin roots, you know that trans means across. A transversal simply goes across two or more lines like this. In the definition, it specifically mentions distinct points. That part is there because this does not count as a transversal. A transversal looks like the one on the left. You know you have a good transversal when the transversal forms these 8 angles. Note we are disregarding the straight angles. I will point out here that we spent the first part of this section talking about parallel. That really should have shown up in the next section because we don't actually use parallel lines yet. We do use parallel next section. Odd. In any case, I drew these lines purposely not parallel because a transversal and everything else to come in this section doesn't need them. You will notice that the definition doesn't mention parallel at all. Now looking at these 8 angles formed by this transversal crossing two lines, if I told you that 4 of these 8 angles were on the interior, which 4 do you suppose would be on the interior? It's these 4. These 4 red angles are on the interior. Most of you would have guessed that without me telling you. You probably would have guessed this too, or really gotten it by process of elimination. But if the 4 red ones are the interior angles, then these 4 are the exterior angles. Keep those groupings in mind as we move forward. There are 4 sets of special angles you need to be able to identify when you have a transversal forming these 8 angles. First up are the alternate interior angles. First you see the word interior in the name, so you know they deal with the 4 angles on the interior. Now what about the word alternate? When you alternate, you do every other one. So if I was going clockwise, or counterclockwise, choosing every other interior angle, I would end up with these 2 pairs. Angle 3 and angle 6 are alternate interior. You can go clockwise from 3, skipping 4, and get 6. Or you can go counterclockwise from 3, skip 5 and get to 6. Either way gets you angle 3 and angle 6 as alternate interior angles. You can do similar things with angle 4 and angle 5. Those are also alternate interior angles. This is the official definition. I am not sure just how useful that definition is, but I think it is easier just to go clockwise or counterclockwise around the interior angles, choosing every other one. These alternate interior angles come up quite a bit, a surprising amount even. Now we have alternate exterior angles. These work just like alternate interior angles, except now we are dealing with the 4 exterior angles instead of the 4 interior angles. The official definition is also exactly the same, except that interior has been changed to exterior. But just like the alternate interior angles definition, I don't know how useful this is. It seems overly complicated. Just look at the 4 exterior angles, go around clockwise or counterclockwise, and select every other angle. You end up with angle 1 and angle 8 being alternate exterior angles. Angle 2 and angle 7 are also alternate exterior angles. Alternate exterior angles are very similar to alternate interior angles, but they don't come up quite as often as alternate interior. They are okay with that. They feel more special and unique that way. Now we get to another set of special interior angles, the same side interior angle. Their name gives away exactly what they are. We have interior in the name, so we are dealing with the 4 interior angles. And there is this same side thing. The same side of what? The same side of the transversal. There are only 2 ways that you can have a pair of angles that is both on the interior and also on the same side of the transversal. Angle 3 and angle 5 are same side interior angles. Angle 4 and angle 6 are also same side interior angles. They are both interior angles that are on the same side of the transversal. On to the last one, corresponding angles. This time their name doesn't immediately tell you what they mean. The official definition isn't much better because you need to know what it means to be in corresponding positions. If you look at our 8 angles, you'll notice that there is a grouping of 4 angles each time the transversal crosses a line. We are going to focus on these groupings. For the top grouping, you can roughly say that angle 1 is in the top left corner. For the bottom grouping, you can roughly say that angle 5 is also on the top left corner. They are on the same corresponding corner. So angle 1 and angle 5 are corresponding angles. We can use similar logic for the rest. Angle 2 is roughly on the top right corner. For the bottom grouping, the corresponding one also approximately on the top right corner is angle 6. So angle 2 and angle 6 are corresponding angles. On the bottom right, we have angle 4 and angle 8. So angle 4 and angle 8 are corresponding angles. Finally, the bottom left pair. Angle 3 and angle 7 are corresponding. So whenever you have 2 lines crossed by a transversal, there are 2 pairs of alternate interior angles, 2 pairs of alternate exterior angles, 2 pairs of same side interior angles, but there are 4 pairs of corresponding angles. This section is all about being able to identify those special pairs of angles. And note, none of them needed parallel lines. They exist even if the lines are not parallel. Why did the book decide to cover parallel this section again?